is 0.25 up to 3.7 meters. And if calculated density is less than 0.25, then the maximum foot distance is 4.6 meter maximum between the sprinklers. So protection areas maximum sprinkle for each type of sprinklers. For non-combustible obstructed, you can expect one question from either of this. NFA 13 also the same. Okay, you can expect one question from the spacing. If they will give you some non-combustible unobstructed surface, what will be the distance between the sprinklers? They will not ask you the same like this, but the content will be like this. Okay, so they will give you some terms like this. What will be the distance from the sprinklers? So such questions you can expect from this. Protection areas and maximum sprinklers base of pendant and upright sprinklers for extra hazard group. The same topic we have covered on NFA 13. The table is repeated. Yes. Maximum distance from the walls. So maximum distance located is 4 inches from an end wall. The distance from the head to the wall normally may be no further than 0.5 times the maximum allowable distance from the sprinkler head. If there is sharp angle in a deep corner, the maximum corner jumps to 0.75. Means the distance between the sprinklers. If you are calculating for the wall normally be no further than 0.5 maximum allowable sprinklers from head to the sprinkler head. If this is for the obstructed area, or if it is a deep corner, in those areas maximum we can go up to 0.75, if you can see here. Okay, the maximum allowable is 11.25. That 11.25 you can get it from this formula, that is 0.75 times the 15 feet. So light hazard occupancy, this is the maximum it is allowed. And positioning of sprinklers to avoid obstruction. Can't hear any sound now. This is for the video, or can you hear my voice now? Those who are in the online.
Yeah, I can hear.
Okay, thank you. So positioning of sprinklers. This is one of the important topics. For 100% sure, you can expect one question from this. Okay, they will ask you a distance of either of this, A, B, D, or they will ask you that. Pardon? Yes. Yes. If this is the obstruction, okay, it's a bead. It's a bead. Okay, you need to have a sprinkler in this position. If you are keeping a sprinkler here, okay, this surface will obstruct for having water or sprinkler in this area. So maximum area this sprinkler so if the sprinkler is here, what happens is this area will be right. So if this sprinkler is here, it can have a maximum coverage of this surface as well. Based on the hazard group, we are calculating the sprinkler distance. This much is the maximum height. If in some criteria, you can see a sprinkler will be kept here. like this. In our upcoming slides, we can see that. Okay, it will not be in the ceiling. It will be lowered bit to cover that area. Types of it is based on the types of obstruction. If you see this type of, here you can see this sprinkler is being lowered bit in order to avoid this obstruction. So it will cover this area. Maybe this area is not required for this purpose, but in order to avoid maximum free space or void space without covering this sprinkler system. Pardon? Yes, that is given. This is A and this is B. From this chart, you can take for each type of pipe size. You can see the distance 1 feet or 300 mm to less than 1 feet of A, is A, and for B, 2.5 inch or 65 mm. So this is one of the important questions. For 100% sure, you can expect one question from this topic: obstructions. Okay, this is another type of obstruction, that is suspended load. The wall is not full. So in those areas, from the edge of the wall and from the top edge of the wall, we have to maintain a distance of this in order to get the maximum coverage area. And all these are for light hazard occupancies. Okay, if you go for the other hazard occupancies, maybe this distance will be a bit closer and it will be a bit lower. It depends on the hazard group. Okay, here you can see the distance of A and B. For each type of obstruction, there is protection areas and maximum spacing of standard sidewall sprinkler systems. For light hazard, maximum distance along the wall is combustible, it is 4.3 meter, and non-combustible up to ordinary hazard, it is 3 meters. So this is the maximum distance along the wall, maximum distance room width, and the maximum protection area. It is being given on the table. You don't have to memorize any of this, okay? But you have to make aware that these are all topics in this NFP. Here you can see some other type of obstruction in sidewall sprinkler systems. So if the dimension of this obstruction is C and D, we have to find what is A, B, and from the chart you can see the distance of A. Position of sprinklers to avoid obstruction along the wall, sidewall sprinkler systems. Be located at a minimum of 4 inch, 100 mm from the sidewall sprinklers. Sprinklers shall be permitted to be spaced in opposite side of obstruction less than 4 feet in width, where the distance from the center line of the obstruction of the sprinkler. So the sprinkler, if you are keeping in opposite direction, the obstruction is less than 4 feet or 1.2 meter in width. Distance between the center line of the obstruction of the sprinklers must be chosen, and does not exceed 1/2 of the allowable distance between the sprinklers. Okay, obstruction on the wall opposite from the side wall. Here you can see, if it is an obstruction like this, distance of A, B you have to maintain. And there is a table for this. Okay, so the minimum distance you have to maintain is 1 inch, and the maximum is 2 inch from the wall. If the maximum of you can lower is this much. This is the position of under beam. If you are keeping this on the beam, this is a beam, and if you are positioning the sprinkler in this position, you have to maintain minimum of 1 inch below this edge of the beam maximum up to 2 inch. You are not permitted to more than 2 inch. And this is the beam size. And if you are moving away from the beam, you have to maintain a maximum of 2 inches. So far it's not this much. There are plenty of examples you can see. I think more than 30, 23, 25 to 30 pages, they are giving only for the obstructions. You can see the trusses, the warehouses, all these obstructions is being given on the topic, but I have given only the sample of this. Okay, if the obstruction is being asked, don't think anything about that. Go directly to this section, and you can see any of you from the position. You can identify which type of obstruction it is. Okay. So fire department connection, we have discussed this on many of our NFPA. Fire department connection normally we are using as 2.5 inches. And 2.5 inches, and the thread you have to mention, there is one special thread, it is NPT, but they have given with some standard. I don't remember how much it is, but in our previous class we have seen that. Okay, that is also an important. Size of the pipe for the different fire department connections shall be, it is not shall be, shall be in accordance with one of the following. Pipe shall be minimum 4 inches for fire engine connection, and pipe shall be minimum of 6 inches for fireboat connections. For hydraulically calculated systems, pipe shall be permitted to be less than 100 inch, but not less than largest riser being served by that connection. So fire department connection shall be located not less than 18 inch 450 mm and not more than 4 feet above the level of the adjacent grade access level. They are discussing this about the standpipe connections actually. Even if it is a fire department connection, the pipe they are mentioning is standpipes. Okay. Fire department connection, fire hydrant, you can see hydrants, fire plug or fire cock is a connection point by which firefighters can take the water. It is a component of fire protection. Hydrant butt, the hose connection outlet of a fire hydrant. These are all some definitions of in this section. You have to study these definitions. Okay, what is a hydrant butt? What is a fire plug? What is fire cock? Each word have the definitions in the definition sections. Pumper outlet, the hydrant outlet intended to be connected to a fire department pumper for use in taking supply from the hydrant. Independent gate valves on 2.5 inch outlets shall be permitted. So valves near the hydrants, valves shall be installed within 20 feet or 6.1 meter of the hydrants. Valves shall be clearly identified and kept free of obstructions. So if there is any hydrants, you have to keep a valve within 20 feet distance. Okay, and it should be marked with, we have seen in our which section, NFPA 14, I believe, PIV valves. Have you remember? Post indicator valves. There is one post is there. Yes, from the bottom we can open. Such type of indicators or something to be easily identifiable for anyone to operate that valves. Okay. Types of hydrants based on functions. There are 2 types of hydrants based on function: dry barrel fire hydrant and wet barrel fire hydrants. So the dry barrel fire hydrants, this is a similar type which we have seen for the deluxe type of pumps. This area will be with compressed air or nitrogen. This will be used in cold areas where the water gets frozen. So used in areas subject to freezing. Drain when not in use, single on-off systems. Stem nut must be opened all the way. This is the stem nut. You can open from the top. If it open, the water from this will go out. Okay, it is like in cold areas like frozen Canada or some areas, those areas the water get frozen. So you cannot, even the water is down, it is free, but top surface it will be get frozen due to atmospheric temperature. Those areas, these dry barrel hydrants are being used. Wet barrel is a common one which we are using here. Okay, used in Qatar. not subject to freezing, always changed, individual hookup. And this is also one of the important topics. Okay, color of fire hydrants. We have seen only red, right? Have you seen any other colors? No. So this is the types of fire hydrants. Red, 8 inches and smaller. Up to 8 inches, it is red color. Okay, if it is between 10 inches to 20 inch, it is yellow color. If it is 20 inch and more, it is green color, and 24 inch and more, it is blue color. So red. Yes, Sajira.
There is a ground level. Ground
Yes.
level to plant development. There is a limit. From
Uh,
the ground level to
uh,
plants.
This area,
No.
this flange,
Yeah.
I think it is 300 mm, 12 inch, I believe, right?
Connection, every color connection, 8 inch, 6 inch, 4 inch. This size is underground.
No, that is pipe size.
Size underground.
Underground. No, he's asking distance from finished ground level flange. 12 inch, that is 300 mm, right? Yes, I believe it is 300 mm. Yes, 300 mm. Final ground level to the flanges. So red indicates the water flow capacity of fewer than 500 gallons per minute, denoted as class C, having a pressure of 20 psi. So orange color is missing. Okay, there is one more color. Okay, orange color is also there. Orange color indicates a water flow capacity of between 500 to 999 GPM. Okay, denotes class B. This is class C and class B having a pressure of 20 psi. Green color indicates a water flow capacity from 1000 to 1500 GPM. And it is class A having a pressure of 20 psi, and blue color indicates between 1500 and more. It is having a class AA having a pressure of 20 psi. The main difference is flow. As long as the flow increases, the color differs. Here in Qatar, this flow up to 500 GPM is sufficient for us. Okay, that is why we always see red color. So this is a rough schematic sketch of a fire connection for a private service line. So there is a fire hydrant connection and main line. There is a service box, and there is a valve over this, I believe. This is the valve which we are saying 20 feet from the fire hydrant. And the black flow preventer device will be there, and it will be connected to the water supply and for the fire hydrant. So here you can see this is the fire hydrant, and within 20 feet there will be a valve box. Okay. What is this named? Truss block. You know, we are aware of that, right? Why you are keeping? It is a restraint joint. If there is any expansion or contraction, it should be accommodated. So they are evaluating the test pressure using a pitot tube. They are opening the. They are testing this. How much is the flow in this? So breaching inlet. There are 4 types of breaching inlets or 2 types of breaching inlets. Breaching inlets are normally located on the ground floor of building to enable the fire and rescue department to connect hoses to supply water into dry riser so that water can be pumped to higher floors. So 3 or more connections, they can keep it and they can pump it. Installation of hydrants. Hydrants shall be installed on a flat stones, concrete slabs, or approved materials. Small stones or an approved equivalent shall be provided about the drain. Center of the hose outlet shall not be less than 18 inch of final grade. Center of the hose inlet. Fire department connection. Yes. No, actually, FDC connection is given to the standpipe systems. Yes, breaching inlet also to the system. Yes. Yes, rises. Pardon? Yes. So the center of the hose outlet shall not be more than 36 inches from above final grade. That is, you have asked, right? What is the from this flange to here? You are asking the distance. Ground level to this flange. That is, I believe it is 12 inch, 300 mm. Okay, and from this to this distance, it should be not less than 18 inches above final grade and not more than 36 inch above final grade. So here you can see this is an FDC connection, and this connection is 18 inches to 36 inches maximum. Okay, that is what we have seen here, 18 inches to 36 inches from finished ground level to the center line of the outlet. And rest of the thing, this is thrust block and gate valve. Gate valve should be minimum of 12 inch from the fire hydrant. It is not given, right? It is not given, but it mentioned it is varies, but minimum it is 20 feet. And the rest of the things, I think it is a general one.
This should go to the patent board.
Yeah. This drawing is available in NFP. The following shall not be installed in the service tub between fire and fire hydrant and private water supply piping. Check valves. It is not allowed to install between the service tub, fire hydrant and private water supply. Okay, you are not allowed to use check valves, detector check valves, black flow preventer device, or similar apparatus. Because if the service line, if there is any water supply required, demand requires, it should have to be, if there is any check valves in between, it's not permitted. Fire protection underground piping. So it will give you the details of this. So it's like a checkpoint. Yes, name of the owner, location, point of complex, graphical representation of the scales. It's like a working plans. So the following items that pertain to private service mains, it gives size, length, location, and weight of the material, point of connection to the city main. So it's like a nameplate. It will give you the information of what is the depth, all these things it will be given. Size of the pipe, length, weight. Size of the fire mains. When supplying a hydrant, 6 inches is the minimum size. When supplying fire protection system, sized by hydraulic calculations and same as the size of the riser. So this is the backflow prevention devices. So here it is a gate valve, and it is a pressure regulating valves, and there is a gate valve in between. These are all the two openings. So differential pressure relief valve, 4 properly located test cocks, and 2 isolation valves. 2 isolation valves and differential pressure relief valves. This is the differential pressure relief valve. 4 properly located test valves. Where is the test valve? There is no test valves here, right? It is not shown properly. And 2 check valves. This is the 2 check valves. Okay. So why we are using? Pardon? Why we are using prevention devices? To prevent the contamination of drinking water supply. If you are connecting to the potable water line with the fire line, if the backflow prevention is not there, what happens? This fire line will backflow to the drinking water. So this is the proper use of fire hydrants. How we have to use? We have to use with the proper threads. We have to open it, and it should be with the wrench. That should be used only on the hydrants. Thread adapters and reducers. When the hydrogen is off position, install appropriate fittings to control the hydrant. So open and close the hydrant valve slowly to avoid the water hammer, bleed off any air, and never control hydrant flow with the stem nut. we have to control with the valve. You should not open the stem net half, and you don't do that. It will damage the thread. Okay. So what is zone control valve? ZCV. Each floor or each zone we have collected, it will be controlled with the zone control valves. So zone control valve is a system designed to operate that area in case of maintenance and to get indication of fire zone on a combination of butterfly valve, flow switch, pressure gauge, and test drain valves. These are all it will be composed inside this zone control valves. We just give it as zone control valves. Doesn't mean that it is a single valve. It contains butterfly valve, flow switch, pressure gauge, and test and drain valves. They are assembled on the fire pipeline to separate the fire area into small distribution zone for indication and fire. So this is zone control valves. You can see there is a gate valve or supervisory switch, flow control valve, and there is a check valve, pressure gauge, and flow switch. There is a drain pipes. Okay, all together is considered as zone control valves. So pressure regulating valves. This is a type of pressure regulating valves. Here you can see how it is being regulated. So if there is no flow demand, it will send, if there is any flow demand, it will center on the gauge, and it will pull out this diaphragm. So depending on the pressure requirements, this diaphragm will be lowered and increased. And if the pressure is more, what happens is this will give the signals, and it will automatically downs, and diaphragm will so pressure regulating valves, it will give you the how much is the pressure required for the line, it will adjust it. Okay, pressure reducing valve, it will reduce the pressure. When whatever the required pressure is required, you can see this is one of the pressure relief valve. This is for diesel pump. Yes, pressure relief valve. So if the pressure is more than the required, it will release, and it will come down, shut off. So the main purpose of pressure relief valve Valve will open to allow the excess pressure to be relieved from the system of a piping network. Pressure relief valve regulates the pressure increasing in a functioning system. Pressure safety valve is rapidly reduces the system pressure to safe operating level. So
This file sharing system shares this file.
yes, it is available. So this is mainly used on diesel pumps, the pressure relief valve, because diesel pumps there will be a fluctuation of pressure always. Okay. So the fire protection piping in a fire hydrant main supply may not be smaller than 6 inches. True or false? True. Water meters are not allowed on fire protection lines.
Meters.
Water, yes, yes, flow meters allowed on fire protection lines, right? It's not allowed.
This is the type.
Yeah, it's not allowed. Yes.
False or not?
Yeah, it's false.
That-
It's
Only this the
not allowed.
this allowed.
Yeah.
This is not-
Okay.
This only for this the bulb.
Yes.
This flow.
Yes. Underground piping must be restrained with thrust blocks. It's true. True.
Calculation.
Yes.
How we can calculate the thrust block?
No, actually calculation is not given for exam point of view, but you can calculate for T there is separate thrust blocks, elbow there is separate thrust blocks.
There's a standard.
There is standard. No, actually the thickness of this concrete, elbow, everything. But for exam point of view, it is not required for you to calculate. They will not ask you how much is the thickness of this thrust block required. No, they will not ask. 100%. they will not.
Depend on the pipe size. Some.
Yes,
maybe like-
no, not only for the pipe size, even for the pipe material. For ductile ion, the thrust block is different, and for HDPE, the pipe thrust block is different. Yes, depends on the material expansion, contraction, and everything. Thickness of the thrust block, there is a calculation for this, but exam point of view, you don't have to worry for this. All fire protection lines must be equipped with a post indicator valve. Post indicator valve is required, but all fire protection lines, it's not required. The top of the PIV shall be set on the top is 40 inches above valve. No, PIV means post indicator valve, like a post you have seen, right? In our NFPA. Pardon? No, that is from the center line to the ground level. That is for the fire hydrant. This is for the valve. This is PIV. Yes, post indicator valve. They are asking for, yes, top. No, it is 40 inches. I don't remember the value actually, but it is 40 inches. Hydrants must be located at least 40 feet from the building protected. At least. Minimum. FP underground may not be run underneath a building. Under a building. There is some criteria, even we can go underneath the fire protection line is under the building, that it is allowed, but you have to place some distance from the beam. I think it is 300 mm or something. You have to keep below the beam, below the plinth. Fire protection underground must be always flushed to provide a velocity of 10 feet per second. That's true. And fire protection underground is always tested at 200 psi. No, it is not always. No, actually 200 psi, but in some cases 50 psi access to the. Yes. So Hydrants must be located at least 40 feet from the building. Should be more than. And FP underground may not be run underground the building. That is true. Oh, sorry.
See, cannot not be run means that's true. You told we can run.
We can run.
It not be run under the
No, actually we can run.
in high rise building. I never seen anything.
No, but in one of the NFPA code, we are studying that there is a permissible, if it is need to go underneath the plinth, we have to maintain a minimum distance of 300 meters from the bottom of the plinth. And there is no answer for this, right? Actually, it is true. And FP underground is always tested at 200, that is false. So, this is all about NFPA 24. It is a very big topic. And next topic will be NFPA 25. Up to this, if you cover all the topics, 60% of your exam portion is finished. 60 to 65%, you are done. Okay. Rest of the topic 101, 5000, 2001, 3 and 4, that are all small topics. Okay. There's 3 topics. That is 101. One, 2000, 2000.
101,
2001, it is available there. Slide. PPT.
Same this one, same it's
PPT. PowerPoint.
Yes.
Yes, already there. Okay.
Input 200 belongs to which NFPA?
Cleaning agent.
NFPA?
It will be from 2001, I believe. It is there. It is there.
You know what I'm.
Yes. If you study 101 and 5000, almost 75% you have covered. So within our next class, I think mostly 70% of your exam topics will be covered. So you can start practicing the questions. Okay. So if you have 40 questions, probably you can cover up to 25 to 30 questions from the topics we already covered. Okay, from 40 questions, 25 to 30 questions, for sure, we have already covered. After the next class, not today, okay? Because 25, 101, I am expecting to take on next class. So next class, if you finish, 70% you are done. No, yes, inspection test plan. It's not a big topic, but life safety code, it's a big topic. Yeah. Inshallah, tomorrow, next class, I will try to cover 2 or 3 topics. 101, 3 or 4, any of 1, and 25. 25, because we don't have anything to explain this in 25, because everything is on the table. Yes, ITM. 22, we haven't covered, right? No, okay. That is it. So, it's not a big 22. Yes, tomorrow. Sorry, inshallah, 22, 25, 101. These 3 topics we can cover. Inshallah.
Phone control wall.
Pardon?
Phone control wall.
Zone control wise.
Installation from standard options there. That is from the butterfly wall to meter from the phone.
No, actually, zone control valve is, if you are drawing, it will be drawn in a sketch, like symbols will be there. It will be written as ZCV, and butterfly valve you can write it as one symbol. And there is no distance. There is a distance, but in exam point of view, it will not be asked. Yes. Yeah, there will be some distance, like. But yes. 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 Yes.
This in table.
No, in the table, it is not there.
Anyway, I can find.
No, this cemetery also is there, okay, we are ready. Student difference also. Because
Pardon?
They are asking to us, not the questions. No, for the airport, not the license.
Ah,
Okay, we
Ah.
should know that everything. So
Ah,
we
yes,
are
yes,
know
yes,
The installation details, everything.
yeah.
Know the civil defense.
Yes, 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 yes. Yes. I think we can wind up for today. You are tired?